We have often been asked, how is it possible to recognize natural electromagnetic signals compared to those of anthropic origin? The answer must take into account some peculiar characteristics that both anthropic and natural signals possess, obviously in a temporal context. Anthropic signals have a main characteristic, namely that of having a very stable electromagnetic frequency, which is visible on the spectrogram, essentially, as a continuous line, and in RDF mode, has a certain color, depending on the position of the anthropic carrier, i.e. its spatial localization with respect to the position of the receiver, receiving station. In RDF mode you can observe several different broadcasting stations, each with its own color, because they are positioned in different places. This feature is essential compared to others. Natural signals, on the other hand, have a less stable frequency trend, if observed over time, and are extremely less stable, if related to a signal of anthropic origin. They often move in frequency, and also have a very wide bandwidth. This obviously depends on the nature of the natural signal. The bandwidth can also include several kilohertz, compared to the electromagnetic frequency monitored by the RDF network developed by the Radio Emissions Project. This is important because it makes us understand very well what the nature of the signals is. As regards the duration of radio signals, these can have a very variable duration, ranging from a few minutes to several hours. The electromagnetic frequency within which natural signals express themselves is highly variable. As a rule, pre-seismic electromagnetic signals can appear mainly between 0 and 5 Hz, appearing as weak and continuous signals at this frequency, or they can appear as very intense pulses that depart from the natural geomagnetic background, 0 Hz, up to reaching 20 kHz of frequency. In this case the signals appear similar to more or less long lines, depending on their bandwidth, but they are dissimilar to anthropic signals because their bandwidth is more intense at low frequencies, and is attenuated until it disappears at higher frequencies.